Yes, hi guys. Today I'm talking about what is the trigonometry. Okay, so the basic point of this trigonometry, I'll talk about what is the trigonometry mean. One thing. Secondly, these questions which are based on trigonometry that are did, and after that everything will be clarified. Okay, because all these questions which are occasionally asked by the students that I have taken here, and after clarification of these questions, I am 100% sure that everything will be clear for the student. First of all, I'll take the definition of trigonometry. What is trigonometry? What is trigonometry? Define it, definition of it. And after that, what are the trigonometric ratios? What is trigonometry is required, and what is the use of it? What is the importance of trigonometry in case of plane geometry, in case of spherical geometry? All kinds of, most of the mathematical branches of mathematics, okay, like differential equations, okay, like differential calculus, integral calculus, plane geometry, okay, coordinate geometry, and spherical geometry. Most of the branches of mathematics is involving trigonometry. That is the important thing I'll talk about. And what is the origin of trigonometry that I'll talk about? Basic definition of this. After that, I'll take the relationship between trigonometric ratios. Okay. Or one trigonometric ratio is expressed in terms of other trigonometric ratios. How? Is the basic definition. Then what are the trigonometric identities I'll talk about? Then the values of different angles in case of trigonometric ratios. Trigonometric ratios in terms of angles I'll talk about. What the values of different angles up to 0 to 90 I'll talk about first, and after that I'll take allied angles also. Okay. I've taken here allied what are the trigonometric ratios, and for functions or circular functions I'll talk about what are the periodic functions. What are the period means what? For example, if it is sine of, okay, I'll talk about what is sine, and after that I'll talk about what are the trigonometric ratios of allied angles that I'll talk about: sine 90 minus theta, cos 90 minus theta, sine 90 plus theta, cos 90 plus theta, etc. I'll talk about. Okay, the other allied angles. Then what are the values of trigonometric ratios of important angles that are important? And okay, let me take one by one so that everything will be clear. Okay, how angle is measured in terms of what is the radian, what is circular functions like degrees, minutes, and seconds, how it is measured. So that is the definition. Now let me take the first definition of trigonometry. Okay, because these questions are occasionally asked by the students. They are not understanding the basis of this. And I am 100% sure that from the beginning, if trigonometry is clear, then everyone is just obvious about one can solve that question based on trigonometry. Okay, so now let me get the definition of trigonometry. Trigonometry is taken is based on what? Let me take the definition of trigonometry. How to define trigonometry? Definition of trigonometry. This is trigonometry. Definition of trigonometry. Now this word trigonometry actually has taken from the two basic words from Greek language. Okay. So here let me first take the first word is trigonon. This is Greek word here. It has been taken from Greek language. Greek word. The two Greek words. First is trigonon. Let me write here. First is trigonon. Trigonon means triangle. That means triangle. And the second is metria. Metria. That means measurement or measure or so triangle measurement or solution of triangles is known as trigonometry. So solution of triangles or measurement of angles of triangles. The solution of triangles is known as trigonometry. Now this is further, if I further explain this, Let me take gonia means angle here, and tri means, or in other words, let me write here, or in other words, tri means 3. Now gono or gonia, this is gonia word. All are Greek words here. This is gonia, that means angle. And again metria, that are already taken, means measure. So measurement of 3 angles, that means triangles. Measure, that is, let me write here, that is measurement of 3 angles. 3 angles is the basic of, or fundamental of, basic fundamental of trigonometry. Now in this case, as I just told you, the solution of triangles is known as trigonometry, or measurement of angles is trigonometry. Okay, so solution of triangles, or measurement of angles of triangles, okay, or solution of triangles is known as trigonometry. Trigonometry is a basic definition of trigonometry is measurement of 3 angles. Here it means triangles. Now triangles is the basic of every study of plane geometry, spherical geometry. Okay, so that is, now let me talk about trigonometry. How it has been taken. Original I'll talk afterwards, but before that let me talk about what is the basic use of trigonometry. Now trigonometry is useful in geometry. First is geometry, plane and spherical. Plane and spherical geometry. So geometry, the study of geometry is basically, finally is configured to the triangles. Okay? Because initially it is quadrilaterals, okay, pentagons, hexagons, everything, but finally it is based on the basic fundamental is the triangle. The study of triangles known as trigonometry. Trigonometry is having basic, the knowledge of trigonometry is useful in case of plane geometry. But in plane geometry, geometrical figures we study, in that the basic is the triangle. Study of triangles means geometry, this trigonometry useful in plane geometry as well as spherical geometry. Geometry, plane and spherical. Spherical here means 3-dimensional geometry, 2-dimensional geometry and 3-dimensional geometry. Plane and this. Okay, then astronomy. In case of astronomy. Okay, so in astronomy we study about the measurement of the altitude and longitude of planets. Okay. So in that case also we are studying about the height, that is longitude, and the latitude here, or the measurement on the plane of the earth, that is longitude, latitude. Astronomy is the basic of in the beginning trigonometry by the studied as the branch of astronomy. So it has been taken from the astronomy. Astronomy is the basic origin of trigonometry. For in trigonometry, we study of triangles here, but in case of astronomy, initially it was astronomy. From the astronomy it has been taken. The trigonometry has been taken from astronomy. Because astronomy we study about length, or sorry, height of the height means longitude, and this breadth means latitude. So latitudes and longitudes are measured in case of triangles. So that is how the triangle is studied. Astronomy. Okay, in astronomy also. Astronomy is also based on trigonometry, or we can just say trigonometry has been taken from astronomy. It's also based on trigonometry. Why trigonometry? Because we study about trigonometry. Study means we are measuring this height, base, and this hypotenuse also in case of right angle triangle. We just measure, for example, this plane is, or let me take the aeroplane. This plane is flying here. Okay, let me take here. This is the object flying in the sky, and after that we are measuring its height, and this is its this is the actual length of the from the angle if we are measuring from this side, but actual height is this. This is the breadth of the point descending of the height on the earth. This is the height here. This height we are measuring. In case of astronomy, it is longitude. In case of this base, I mean the length on the base or on the earth, latitude here, longitude, latitude, etc. we are studying in astronomy. But astronomy is also having, because this trigonometry has been taken, as I told you, from astronomy. Initially it was a branch of astronomy. Trigonometry having used in case of plane geometry, spherical geometry, astronomy, even differential equations, differential calculus, integral calculus. That is full of trigonometry illustration. Trigonometry is useful in case of almost all kinds of branches, all branches of mathematics. Some are there. For example, algebra is not involved in trigonometry, but plane geometry, geometrical field. So this is definition of what is trigonometry. We have told you about trigonometry is the study of solution of triangles. So three angles we study about, and this is the Pythagoras theorem mostly used in case of finding the trigonometric ratios. Second point is what are the trigonometric ratios. This definition of trigonometry we have discussed about. Okay, and the second point is question number 7. What are the trigonometric ratios? Let me talk about trigonometric ratios. What are the trigonometric ratios? This is the second question here. Trigonometric ratios. How they are calculated? This is just talk about them. Basic definition. Now, in case of, you know that right angle triangle, in which one angle is the right angle, 90-degree angle. Okay, and this is the right angle triangle. If I take this angle, equitriangle as theta, or it is alpha or theta, whatever we take. Okay, then by Pythagoras theorem, this is the perpendicular here. The angle which we consider, the side opposite to that angle, which we consider is the perpendicular. This is the perpendicular. Let me take this as ABC. Here BC is the perpendicular. BC is the perpendicular, and AB is the base here. This is base, and this is known as hypotenuse by Pythagoras theorem. This is hypotenuse. Okay, so using Pythagoras theorem, by Pythagoras theorem we know by Pythagoras theorem. Okay, by Pythagoras theorem, or we can just see Pythagoras theorem, we have, what is that? Pythagoras used to say, or he invented that the square of one side of a triangle which is opposite to the right angle triangle, the side opposite to right angle is the hypotenuse. The square of hypotenuse is equal to sum of the squares of the other two sides. Here, let me take AC square is equal to AB square plus BC square. This is by Pythagoras theorem. By Pythagoras theorem we have AC square, side of one side, square of one side equal to sum of the squares of the other two sides, and here this one side is the longest side, this is hypotenuse in this case. In this case this is hypotenuse here. In right angle triangle only Pythagoras theorem is applied. So in Pythagoras, by Pythagoras theorem we know that this is the following. Okay. Let me take this is the first problem here. I have to find out what are the this is trigonometric ratios, so the identities we are calculating. What are the trigonometric ratios that are there? Okay, so this perpendicular upon hypotenuse, base upon hypotenuse, perpendicular upon base. There are three basic trigonometric ratios. trigonometric ratios I'm talking about. These are the trigonometric identities I have to calculate. And before that, let me take this base here, and let me take this y, and this is base is, okay, let me take this is p, perpendicular, this is base p, and this is hypotenuse h. Then the trigonometric ratios, what are the trigonometric ratios? Then sin theta, which is, let me write here, trigonometric ratios are, first is sine of this angle theta. Sine of angle theta will be calculated. Sine is this perpendicular upon hypotenuse. Perpendicular upon hypotenuse. This is hypotenuse. Okay, P upon H, or simply we write it as P upon H. This is sine theta. Sine of any angle, acute angle here, acute angle we have to take here. Sine of that angle. So, solution of triangles. Here, solution of triangles means the basic definition of trigonometry is the solution of triangles. The solution of triangles means when the sides are given, then you find out some trigonometric ratio. If some sides are given, then angles are to be calculated. If angles are given, or okay, area is given, then we can find out what are the other sides or the angles. So solution of triangles means we have to find out what are the angles of that triangle, values of the angles, what are the sides of that triangle. Solution is finding all the 6 things, 3 angles and 3 sides, the value of them, is known as solution. Now in this case, trigonometric ratios I am talking about. There are basically 6 trigonometric ratios. Basically 3, and the 3 are reciprocal of them. What are the reciprocal trigonometric ratios I am talking about, and what are the trigonometric ratios? First trigonometric ratio is sine of that angle. This is not sine of theta angle. Sine of any angle, this is suppose sine 30 degree, or calculate the value of some angles of these trigonometric ratios. What are the values of trigonometric ratios for certain angles up to 0 to 90 degree or before. But before that, what is sine theta? The sine of the acute angle, sine of acute angle is equal to perpendicular upon hypotenuse. Now here perpendicular is taken side opposite to the angle which we consider. If we consider this as theta, and this will be perpendicular, the side opposite to this angle. But in this case, this theta we are considering. Okay, the angle AB are considered. CAB angle is being considered. So the sine of this angle theta is perpendicular to hypotenuse. We have to remember some basic points here. With that, sine theta P upon H. Then is another trigonometric ratio is cos of theta. Cos of angle theta. This is base upon hypotenuse. This is base upon hypotenuse. This is known as base upon hypotenuse, or B upon H. That is third trigonometric ratio, which is important. Again, they express in terms of sine upon cos, but tan theta, which is P upon B, or perpendicular upon base, or this is equal to P upon B. This is basically P upon B. These are 3 basic trigonometric ratios. The trigonometric ratios I'm talking about. These basic 3 trigonometric ratios, and 3 others are there. Total 6. What are those 3 others? 3 others are just reciprocal of them. The reciprocal of this is the reciprocal. What are the reciprocal ratios? Reciprocal ratio is cosec theta. Cosec of this angle theta is just opposite H upon P. This is 1 upon sine theta. The reciprocal of sine. Reciprocal of sine 1 upon sine is cosec theta. This is cosec theta, which is the reciprocal of 1 sine, which is 1 upon sine. Then second is, next is second theta. Second theta is 1 upon cos theta. And then cot theta. which is the reciprocal of tan theta, so it will be 1 from tan. So 1 from sin theta. So these three, cosec theta, secant theta, cot theta, are the three other trigonometric ratios, and they are reciprocal of the first three, but we can say that these are 6 trigonometric ratios, which are three of them are reciprocal of each other. We can say that sin theta is reciprocal of cosec theta, and cosec theta is reciprocal of sin theta. Sin theta and cosec theta are reciprocal of each other. Similarly, sec theta, cos theta, sec theta, they are reciprocal of each other. Tan theta and cot theta, they are reciprocal of each other. We have to just remember the three basic trigonometric: sine, cos, and tangent. Tan theta, sin theta, and cos theta. Then the three others are just reciprocal of them. So if you remember them, then what is the basic value of these three angles? These are trigonometric ratios. Let me just talk about them. For that, we have to just remember one formula. Let me just talk about that. And this I'll talk about what are the identities of trigonometric identities. We have talked about what are the signs of trigonometric ratios in different quadrants that are there. And now I'm talking about question number. What are the trigonometric ratios? Second question we are talking about. What are the trigonometric identities? Then I'll talk about this. So just to remember trigonometric ratios, just to remember the trigonometric ratios, the values of, let me write here, the value of trigonometric ratios. Trigonometric ratios. One has to remember the formula, the basic formula. This is basic formula, which is known as P divided by HB. These three, PBP upon HB. Now, as I just discussed about, this P upon H perpendicular upon hypotenuse is sin theta. Now, this first is sin theta. So, sin theta is P upon H. And the second is cos theta, which is based upon hypotenuse cos theta. This value is B upon H cos theta. And the third one is tan theta, perpendicular upon this tangent of theta. So P upon B tangent of theta. So I've just explained that the side opposite to the angle which we are considering, here theta we are considering, tangent of theta angle is perpendicular. Perpendicular is just side opposite to that angle which we are considering. If we consider this as this acute angle as the basic angle which we are considering, the value of the ratios, trigonometric ratios of that angle we are considering, then the side opposite to this angle means this will be perpendicular, other will be base. And hypotenuse is not changed. It is always opposite to the right angle triangle, right angle. This 90-degree angle opposite to this side is always the hypotenuse. Only the perpendicular and base, they are interchanged. They are to be considered in a proper manner. The angle which we are considering, for example, if I find out the ratio of this angle, then this is perpendicular, this is base. And if I consider this theta as the acute angle, or the ratios of this angle we have to calculate, the side opposite to this angle is perpendicular, this is base. So the base and perpendicular, they are very important. Which is base, which is perpendicular in a particular right angle triangle, that is the most important point to understand. Okay, and we are to remember. So remember that the side opposite to the angle which we are considering is perpendicular to the other side of base. In this case, it is perpendicular to base. The hypotenuse is always constant. I mean that remains constant. That cannot change. That is always opposite 90-degree angle. Okay. This is hypotenuse. Now from this okay, now I'm just explaining this. The first ratio P upon H. P upon H. The bend upon hypotenuse is sin theta. B upon H is base upon hypotenuse is cos theta. I just explained. Then tan theta but P upon B. Now in this case P upon B, opposite of them, reciprocal of them, H upon P, H upon B, B upon P. This B upon P is cos theta. The reciprocal of tan theta is cos theta. 1 upon tan theta is cos theta. That is B upon P is cos theta. H upon B is secant theta. H upon P is cosecant theta. Cosecant theta is the reciprocal of sin theta. Okay. So reciprocal of sin theta, we can say that cosec theta. The reciprocal of sin theta is 1 upon tan theta, as I just explained here. Reciprocal trigonometric resource is cosec. That means cosec theta is nothing but H upon P, hypotenuse upon P. In terms of values, the values are given of, or sides are given of a right angle triangle. Then in terms of that, you can find out these sides here. Suppose this H is 5, P is 4, this is 5.4. Cosec theta is 5.4. That means take here, P is 4, this is 3 here, and this is 5. So in terms of numerical values, I just find out that cosec theta is the opposite of sin, 5 by 4, it will be 5 by 4. Okay, so in this way we calculate the value, but and then opposite is the cosec theta of sin theta, reciprocal, and secant theta is reciprocal of cos theta. Secant theta is 1 upon cos theta. Now secant theta is 1 upon cos theta. That means now 1 upon cos theta is B upon H. That means H upon B. This is H by B. Cos sec theta is hypotenuse upon base. Hypotenuse upon base. So in terms of sides, we have to measure the angle. I mean trigonometric ratios. The value is H upon B. What is H given? 5. B is suppose 3. 5 by 3. This is 5 by 3 here in this case. So this is how in terms of sides or coordinates we can find out these trigonometric ratios. Okay. The second is reciprocal of cos theta. Similarly, cot theta is the reciprocal of tan theta, as I just explained. Now, tan theta is P upon P. This is 1 upon P upon P. That means B upon P. Base upon the perpendicular is cot theta. Because cot theta is a reciprocal of tan theta. This is 1 upon tan theta is cot theta. This is how cot theta value is. Now, just to remember these ratios, or always this PVP on HHV, just to remember that there are certain formulae, certain dictums or sayings which are remembered by the students. Okay, in case of they say mostly in Indian villages or even in Delhi I have found. Okay, in New Delhi I have found that most of the students remember in patriotic sayings. They say Pakistan bhuka pyasa, Pakistan bhuka pyasa, Hindustan hara bhara. This is patriotic saying. They say that India is green and developed. Hara bhara means it's full of prosperity, it's prosperous, and green means hara. And Hindustan hara, that means it is fertilized, developed, it is green, that prosperous country. And Pakistan is hungry and as well as that is Pakistan is bhuka means hungry, pyasa means is requiring water, lack of water. It is Pakistan भूखा कैसा, Hindustan हरा. In this way they remember. Pakistan भूखा कैसा, भूखा about in Hindi is hungry. Okay. And this is requiring water. I mean, it is lack of water here. Okay. That means, okay. So this is how the people remember here in India. So Pakistan भूखा कैसा, Hindustan हरा. That is how they remember. Okay. So or we can in English we can just say, okay, any word we can remember in English, but in Hindi we remember in this in patriotic terms. We remember that Pakistan भूखा कैसा, Hindustan हरा हुआ. That means P upon H sin theta, B upon H cos theta, P upon B tan theta. That I have already explained. So now, just to find out the sides in terms of sides, trigonometric equations in terms of sides, then we have to remember this relationship. P upon H, B upon H, P upon B. P upon B last is tan theta. This is cos theta, this is tan sin theta, first one is. Then reciprocal of them, cosec theta, second theta, and cos theta. Okay, they are the 6 trigonometric ratios. Now let me write these 6 trigonometric ratios. The question number 2 we are talking about. Second question is having what is trigonometric ratios? There are 6 trigonometric. First is sine of theta. This is P upon H. P upon H. Second is cos theta. Cos of this angle. Cos of theta is equal to B upon H. Base upon hypotenuse. Perpendicular upon hypotenuse. And third one is tangent theta. Tan of theta. This is P upon B. Perpendicular upon base. Perpendicular upon base. In right angle triangle. In right angle triangle only we can find out these trigonometric ratios. If any triangle which is given, suppose that is not right angle, we put the perpendicular, make it right angle triangle, and then we can find out these ratios. This is how the other 3, which are reciprocal trigonometric ratios. Reciprocal of sin theta is cosec theta. Is cosec of this theta angle. This is A here. Cosec theta is equal to H upon P. Hypotenuse upon perpendicular. And it to okay, cos theta reciprocal of this is second theta. This is second theta. That means 1 upon cos theta or equal to B upon this is H upon B. So cos theta is B upon H. H will come in the numerator. This is H upon B. Okay. Numerator 6 through